I don't know why Zoom does that now. It just started today. It tells me that I'm recording. Never done that before. You've heard that before?
Yeah.
Yeah?
Like
just recently?
Like
I don't know why is mine just started? I don't know. It's so weird. It has never done that ever before. And I've recorded 180 days of school. Well, not quite yet.
It's on the iPad.
I don't know, but I always use the iPad. Oh, maybe. I don't know. It's so weird. All right, so looking at 21. 21 says, find any points on the graph of f of x whose tangent lines are horizontal. And we have 3x squared minus 2x plus 1. So that would be our function. And if you're thinking about that function and what it looks like, anything that's x squared, I'm just drawing a little graph here. You know, anything that's x squared is going to be some type of parabola. Something like that. So our goal is to find any points on this graph, which there's just going to be one. But if it was a function of x cubed or x to the fourth, then we could have a couple locations where the tangent line would be horizontal. But we're going to have one location where it's horizontal. So in order to answer this question, find any points on the graph of f of x whose tangent lines are horizontal. What do you have to do first? So like, what's the first step that you would need to think about finding? How would you find a tangent line that's horizontal and points on that graph? Peter? Yeah, and why do you need to do that? Right, that gives us the equation for the slope of any tangent line. So the first thing that we need to do is to find the equation that represents the slope of any tangent line on this graph, so that we can specifically then find a horizontal tangent line. So we're going to have to find that limit as h approaches 0, and then f of x plus h minus f of x over h. So that's the first step. This represents the formula for the slope of the tangent line. It also represents the derivative. Same process, represents two different things. Graphically, the slope of the tangent line formula. Algebraically, it's the derivative. So when you apply that to this function, we're replacing the x with x plus h. So we have 3 and then x squared minus 2 and then x and then plus 1. And then again, anytime you see an x, you're replacing x with x plus h. So it still is 3x squared minus 2x plus 1, but we are replacing x with x plus h. You have to do that twice because there were 2 x's. Then it says subtract f of x. So we are now subtracting all of f of x, and that function is the 3x squared minus 2x plus 1. And that's all over h. So this is a big one because we have 3 terms. So there is some foiling involved, distributing, combining like terms. And don't forget, when you FOIL the quantity x plus h squared, that whole quantity gets multiplied by 3, not just the x squared, but all of it. So I have it FOILed right above it. That quantity has a 3 in front. So whatever you FOIL, all of that also has to be multiplied by 3. So I would say that is a common mistake that you could make, not distributing the 3 to the entire quantity. So this becomes 3x squared, 6xh, 3h squared. And then there's a negative 2x and a negative 2h, and then that plus 1. The second mistake that could happen, you have to make sure you're subtracting f of x. Well, f of x is 3 terms. All 3 of those terms need to be subtracted. So we have a negative 3x squared, but a positive 2x, and then a negative 1. So when quantities are grouped together, make sure that that entire group, the 3 is applied to the entire group, or the negative sign is applied to that entire group of terms. And then that's divided by h. All right, Hannah, huge expression here. What can we cancel? Simplify.
The 3x squared and then minus 3x squared, negative 2x and positive 2x, and then the 1.
Yeah. So whole bunch of terms cancel. Remember, after those terms cancel, the terms that you have left, in this case, there are 3 of them, they should all have an h in common, because that h in the denominator, that's what's making it undefined. And we need that h to cancel so that we can continue to evaluate the limit. So if we take out the h, we have a 6x, a 3h, and a -2. So the h cancels, and now you can evaluate the limit by replacing the h with a 0. So your slope, which is the derivative, depending on how the question is asked, is the equation 6x minus 2. So that's the equation for the slope of the tangent line. That's also the derivative. Questions? All right, so we needed to do that part first so that you could have a formula or equation to represent the slope of any tangent line. So now if we look specifically, it's saying find any points of the graph of f of x where the tangent line is horizontal. So looking at our little graph here that I kind of drew, a horizontal tangent line is going to be at the vertex of the graph. Let's pretend that looks horizontal, it's slightly off. Darby, how could I find the point on that vertex by using the slope of the tangent line or the derivative?
You could plug in some facts or like the derivative equation.
What do you know about the slope of a horizontal line? It's 0. Yeah, the slope of the horizontal line is 0. Again, the formula that we just found is slope, is the derivative, is 6x minus 2. So if I want to find a point, and I know the horizontal line has a slope of 0, I could take that 6x minus 2, which represents the slope, and find x, which is 1/3. And then Cole, once you have x, how could you get the corresponding value? Yeah, so go back to the original equation. And we want to find y, or f of x. We need its other value to have that ordered pair. So you're finding x by using the fact that the slope is 0. After you find x, go back to the original function, because the original function is going to get the corresponding y value. So 1/3 squared is 9, or 1/9. And then that's minus 2/3, and then plus 1. So I think that's positive 1/3. Yes? Yes. So the point is 1/3, comma 1/3 when the slope is equal to 0. And is it 2/3? That's a negative one. Yeah, it would be 2/3. That's a negative 1/3. Yeah. Change that. So this makes, yeah.
Your equation, 3x squared.
So plug the 1/3 back in. 1/3 squared is 1/9, so that's 1/3. That's negative 1/3 plus 1 is 2/3. Yeah. So kind of understanding what is the question actually asking you to do. So if you're trying to find a tangent line, you need to use the process of finding the formula for slope. And then a horizontal line specifically has a slope of 0. But we didn't have to have a horizontal line. So I could say, find the point where the slope is 2, or find the point where the slope is -1/2. But this one specifically asked for a slope of 0. But you could find a point anywhere on the graph of any given slope by using the formula that we calculated, that 6x minus 2. Good question to ask. Other questions, Parker?
You know, the finish line.
2/3. Yeah, ask for the end y, the y value, right? Is that what you asked for?
Yeah.
So when the slope is 0 of a horizontal line, the point where they're connecting is at 1/3, 2/3. That would be where the vertex is. Hannah?
Can you do 18 each?
Yeah. Yeah, this is a good one. So I have my graph up here. All right, so let's look at the graph. So we have f prime of 0. So again, that's derivative notation, but it really means find the slope. The derivative is the slope is the derivative. So we're finding the slope when x is equal to 0. Again, there's that little prime symbol. So in our little graph, here's our piecewise function. The first thing that we're going to do is to find when x is equal to 0, which is of course right here on the y-axis. And then if you go to the line, so x is equal to 0 right here at this location on my line. I need the slope of that line that contains the x value of 0. So Hannah, what is the slope of that line that would contain that point? 1. So h f prime of 0 is equal to 1. So let's do I as well, just so you can see how to look at I. So this says f prime of 3. So I want to find the slope when the x value is 3. So if we go up to our graph, here's x is 3. Up here on my graph is where x is 3. So what is the slope of that line that contains the x value of 3? That's what that question is really asking you for. So in this case, it's a horizontal line, and Darby, the slope of a horizontal line is 0. So f prime of 3 is equal to 0. So again, you're finding the slope of whatever line is contained at that x value. Slope when x equals 3. So those two questions, you're finding the slope, but letter E and F, you're really just finding the y value. That's just point notation. So if x is -1, then what is y? Well, x is -1, y is +1. So f of -1 is equal to +1. So questions asking different things based off of the way they're notated. Parker, question. Yeah, let's look at C. Yep. So 18C says this one's a limit question, and we're approaching 2 with a little minus after it. So this means 2 from the left. So on the graph, I actually have 2 highlighted here, but I need to be on the left side of 2. So the left side of 2 is the left side of the graph. And you need to pick the piece of the graph that would be to the left of it, directly to the left. Well, that's this horizontal, or not horizontal line, diagonal line. So if I'm approaching 2 from the left, we need the y value. So as we're coming in from the left, going to the value of 2. So you're approaching the value of 2, the y value, Parker, is the 4. Yeah. So. Yeah, there isn't one that says the limit is just x approaches 2. But the previous one for letter B says 2 from the right. So now I'm on the right side of 2. And that one's at 5. That one's not reached because it's an open circle, but it still approaches it. It gets really close. So letter B should be 5. Remember, just because there's an open circle doesn't mean it doesn't exist. It just means it's not reached. The only time a limit wouldn't exist is if it goes to 2 different y values. So if it just said the limit as x approaches 2, that one wouldn't exist, but that question isn't on there. Other questions? These are good questions. Anna?
So, for, how would you like number 11?
Number 11. Oh, I would look at 11, 12, and 13. I would graph them on the calculator. That's a good question. So algebraically, you can factor, you can rationalize, you can find common denominators. But if it's not one of those 3 options, like number 11, then I would graph those. So make yourself a little sketch, a graph. A sketch of a graph is just a way to evaluate a limit. So algebraically, substituting, direct substitution, factoring, rationalizing, common denominators. And if you can't do any of those, then you're going to have to graph the function and just show a little graph for 11, 12, and 13. But anytime you have absolute values, that's when you're going to have 2 horizontal lines. So you should have 2 horizontal lines going into the value. But I would graph those. Other questions? All right, so I will give you the remaining time to